Okay, this is our last day on our dance, and today we're talking about refreshments. Okay, so we know that refreshments cost $10 per person plus a $15 setup charge. And we want to represent the relationship between the number of people and the total cost for the refreshments. Okay, so let's set up the table. We know that we're looking at the number of people and the total cost. Okay. All right, so thinking about a dance, as we're going to set up our table here, thinking about a dance, dances typically have a lot of people, so it wouldn't make sense for us to count by ones in our table. Okay, so maybe we should count by like tens, or maybe even 20s. Yeah, let's do tens. So 10, 20, 30, 40, 50. Okay, so process. Let's take a look at that. Actually, I want to go back and change it. I do want to count by 20s so that we have more data. So let's do 20, 40, 60, 80, 100. Okay, so let's talk about process. So if we have 0 people purchasing refreshments, then we're not going to charge the $10 because 0 people are purchasing refreshments. But if they're there, there's still a $15 setup fee. Okay, so the total cost would be $15. Okay, let's talk about 20 people. If 20 people come, and each of those people are charged, are charged $10 for refreshments, that's $200 plus 15 gives us $215. All right, let's look at 40. $10 times 40 people gives us $400 plus 15 is $415. And I'm just going to continue the same process. To fill in the rest of the table. All right, so there's a bit of data right there. So let's go ahead and let's set up our graph. Okay, so we know that, again, all of our numbers are positive. So I am just going to show quadrant 1 on my graph because we don't need to show any negative values given our context of our problem. Okay, and let's go ahead and give some labels. So I know that my x-axis is going to be the number of people. And I know that my y-axis is going to be the total cost. Okay. And let's go ahead and let's scale these axes here. So we have from 0 to 100. So if we count by tens, let's see what that would do. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We can fit that. So let's do, let's count by tens, but I'm only going to label every other grid line just so that it's not super smushed. And I can actually extend this all the way to 160. Okay. All right, and then we're going to look at our y-axis. So our y-axis, we need to get all the way up to 1,000. So if we need to get all the way up to 1,000, geez, we might want to count by 50s to get all the way up to 1,000. So let's take a look. If we go 100, 200, that should be good. 300, if we're counting by 50s, we should get pretty far up there. And I'm just labeling every other one. So we're counting by 50. I'm only labeling the hundreds. And we can get up to 800. That's fine. That's enough. So we might not get that whole picture on our graph, but we'll still get a good chunk of it. All right, let's have a look. So if I have 0 people, then the cost is going to be $15. So I'm going to have to estimate that. If I have 20 people, it's going to cost $2.15. Again, I'm going to have to estimate where that is. 40 people, $415. 60 people, $615. 80 people, $815. And I can't fit any more than that on the graph, but that's a good picture. So that's a good picture for us. All right, so now we're going to write our rule. And I'm always starting by writing my skeleton. Okay, since we're writing our rule, we know that we need to find our slope and our y-intercept. So our slope we're going to find by finding the change in y and the change in x. So what is going on between all of these values? Well, I'm adding 200 between all of those values. Let's take a look at the change in x. What's going on between my x values in the table? I'm adding 20. Okay, so if I'm going to find my slope, we know that slope is the change in y divided by the change in x. So I'm going to take my 20, or my 200, excuse me, and divide by 20, and that gives me 10 as my slope. I'm going to go ahead and write that in. And then I also need my y-intercept. So I want to find my y value where x is 0, and that happens to be 15, so that is my y-intercept. Okay, keeping in mind that it's also a good idea to define our variables so that we know what our equation represents. So x is the number of people, and y is the total cost. And just like the last 2 days, we have 2 follow-up questions. Okay, so the committee is estimating that 60 to 120 people will attend the dance. How much will refreshments cost for that number of people? Okay, so we know that 60 people cost $615, and I'm just finding that from the table. So 60 people cost $615. And then I can use the rule for this one, but if I look at my table, I can extend my table one more time in both directions. So I can add 200 on my y side, and I can add 20 on my x side to get that value. Okay, so we know that 60 people is $615, and now we know that 120 people is $1,035. So we can answer that question from the table. So $615 to $1,035. Okay, so we use the table because 60 was in there. And it was easy to extend, or quick, I should say, quick to extend to 120. Okay, let's take a look at the next one. If the committee wants to keep refreshment costs under $1,000, what is the maximum number of people who can attend the dance, assuming they all want refreshments? Okay, so we can look at the table for this, and we can see that it's probably close to 100 people, because 100 people cost $1,015. However, we cannot get an exact answer using the table. And our graph doesn't go up to 1,000, so we can't really use our graph either. So we're kind of stuck with the rule. So if I look at my rule, and I think about where I want to substitute 1,000, well, 1,000 is a total cost. So that's going to substitute in for y. And then we're going to have to solve. So I have $1,000 equals 10x plus 15. And then we're going to solve this. Okay, so we're going to solve first by getting rid of the plus 15. To get rid of the plus 15, I've got to subtract. Okay, so that leaves me with 1,085 equals 10x. And then I get to divide both sides by 10 to get rid of the 10. Okay, and if I do that division, that tells me that 108.5 people is what x is equal to. This doesn't make sense in the context of our problem because we can't have a fraction of people. Okay, so if we think about this, $1,000 is what 108.5 people would cost. So if we round it up to 109 people, that's going to go over $1,000. So we have to round down to 108 people to stay under the $1,000. Okay, and we'll just say we use the rule. Because $1,000 was not shown in the table or the graph.